Hello everyone, thank you for coming for my talk. It is second day, quite lately, so we are quite probably tired, but let's make even a harder session just to make it even harder. My name is Konrad Kokosa. I wrote this book, which you can win. Listen carefully. It's, oh my god, 2 kilograms. It has this nice capability of staying on and on, so you can use it also like that. Or read it eventually. So listen carefully. I will ask very simple question at the end of the presentation. You can win it. And the title of the talk is Writing Custom .NET GC. The agenda of the talk is why we should even care about something like that, like custom .NET GC, what we have to write, what we have to do to write it in general, how we can write it something which is at least working, which would be quite nice feature, that it is working, doing something. How we can write something which is useful, which we, let's say, can be used on production with a very big, let's say. At least start writing something like that. The very first quite important question, how many of you have attended my talk in Moscow about this similar topic? Okay, not very much, so very nice. Welcome to the world of custom GCs, which is unfortunately not existing at all, in fact, because we don't have something like custom GCs. At least we didn't today, let's say, in the approximation. So why we should even care about something like custom .NET GC? In general, if someone of you is familiar with JVM world, have you even written something in Java or something? Okay, few people. So you can at least see that it is possible to change GC in JVM. Yep, they have various. It's not very visible, I believe, this laser point, but they have various JVMs that they can choose, and they configure it even more, fine-tune by various parameters. A lot of them, there is possibilities with how they can fine-tune them. Probably not everyone understands what it does, but at least they can copy-paste it from Stack Overflow and have this chance that it will be better fine-tuned than the default. But they have this quite big possibilities about how they configure the GC and even choose the GC. Because the GC can be seen from various perspectives, how, for example, how big CPU overhead introduces, or how the memory overhead is when we are using such GC, whether it is pauseless or not, whether the pauses are long or not, what is the latency, what is throughput. So obviously, there is no ideal mechanism that would be ideal for all possibilities. So we can create probably GCs tuned for the particular points which are mostly important for us. But in .NET, we have not very flexible at this field. We have this, let's say, level 0, so the most simplest one, way of configuring GCs, which are GC modes. Have you ever changed GC mode in your app? At least some people were changing, so you are aware of that. You have this possibility, you have four possibilities, which is not very big, obviously. And this is only kind of fine-tuning how this GC is working, but it doesn't change the GC itself, obviously. Then we have level 1, let's say, that allows you to customize it a little more, and it is a little bit similar to the JVM world. We have, for example, GC heap count, which reduces, and we can limit how many CPU cores your GC is seeing. You can use latency modes or latency optimization goals, which is the kind of new thing that is going to be introduced to .NET runtime. For hardcore programmers, you can host your own CLR and then fine-tune some things. But still, this is only a little, very little possibilities. Yep. In .NET Core, the thing is a little bit better because you have those configuration knobs. There are a lot of them exposed. You can set them by environment variable, for example, and there is a whole section on configuration knobs for GC. So you can look at this documentation on GitHub, quite a lot of possibilities. And some of them seems at least quite interesting. For example, you can change the compact ratio. So force, what is the ratio between compacting and sweeping GCs? Or what is the threshold when the object will land on the large object heap? The evergreen question from recruitments that it is 85,000 bytes now is not valid because you can change this limit by this configuration knob. What is the segment size? What are the default sizes of generation 0, and so on and so on. You can, I don't know, enable logging, but still, this is only small fine-tuning. You don't have possibility here to change the algorithm or even change the policy how this GC is working, and very small fine-tunings. So there is no middle ground. Instead of level 0, 1, we can go a maximum way. We have just to use custom GC. So it is level max value because it's the hardest one. So we can what you can do with it, in fact, we can do only one thing. We can only replace the whole GC. The whole GC mechanism. There is a runtime, there is a default GC, we can just kick it off and kick in our own new shiny GC implementation. So the whole mechanism. And we can simply replace a part of it. We can't, because we can only replace the whole mechanism. And this is kind of disadvantage because a lot of people would like to fine-tune the default one, not the right new one from scratch, but currently it is not possible. So our ultimate goal will be to write the better GC for .NET, better than the current default, which is kind of, haha, good luck, because they are writing them from 15 years or something, so it's not easy at all. But it is our ultimate goal. The realistic goal, let's making anything that works. Seems more reasonable. And learn something. So from the point of the pirates, how they seeing world, I would draw such custom .NET GC ultimate map, and we are seeking for this treasure which is living on the concurrent, compacting, ultimate, super GC island. And we are trying to reach this land and find this treasure which will be the better, the most sophisticated GC in .NET. And it's somewhere we will have to start from. So let's write this minimum valuable product, 0 GC, which doesn't seem very sophisticated, because it's only allocating and have no GC at all, because this is the most simplest thing that we can write. So from the way how pirates are seeing the world, we can draw the 0 GC island, the island without GC at all, and we can start from there, at least to see what it is and how we can use it. So we are starting from there, somewhere on the bottom. Exactly like they did in Java. If you, maybe you are aware or not, there is something like epsilon GC in Java, which is exactly that. It's a 0 GC for JVM. It is a experimental GC written for exactly that purpose. And if you look for a summary of its design, it is well described. It is developed and develop a GC that handles only memory allocation but does not implement an actual memory reclamation. It has no GC. So it is a completely passive GC implementation, epsilon GC in JVM. And the motivation on this is quite nicely documented also on the JVM pages. So, for example, one of the reasons is performance testing. If you have a 0 GC, which is doing nothing, it is a great thing which we can compare to when we have to compare the performance of a real GC, because we have something which does nothing and is plugged into the runtime. Then we have our GC and we can compare them in terms of performance, memory usage, CPU usage, and so on. So it is nice. Also memory pressure testing, because let's say if we don't collect garbage, we quite fast will be full of the memory because of the allocations, because we don't reclaim the memory. So if our application allocates a lot, we're using 0 GC will be a perfect way to notice that, because we will hit out of memory exception very fastly. All testing the whole interface between the virtual machine and GC obviously, when we want to test it, we have to implement it, and implementing it in the easiest way is the easiest way to find out whether this interface is good, whether the API of the GC between the virtual machine and the GC is okay or not. Then, from the more practical way of seeing zero GC, we can, for example, try to use it on production even for a very short-living jobs, like serverless functions, which are just simple processes that are started doing its one or two things, and then the process is being killed, so there is no sense in reclaiming memory because the whole process will be just closed soon, so why to bother about garbage collection? So we can get rid of garbage collection and just use something like that in, for example, serverless environments. And improving the latency, because obviously when there is no GC, there is no GC overhead. So if we are fighting with very, very short, very, very fast, high-performance code, and we are controlling it in a way that it is almost no allocating, it is nice to just get rid of GC, because we are taking care of garbage-free applications, and I mean there are no allocating, so why to bother about GC? So there's also kind of a practical approach when we could use it. And from my point of view, it's also a good template, because we now have a very minimal product that we can start from if you would like to write something more sophisticated. For obviously, this is also a perfect way of learning how to write such GC and how the whole runtime runs, and also quite a bit of fun, at least for me. So, summary. Why we even care about something like .NET Custom GC? Because the default one is default configuration possibilities are quite limited, and those fine tunings are quite limited, and because it promises us to create something better, at least in 15 years, let's say, but we have to start from somewhere. And even more something, more configuration, more logging, more something, because we can have our custom needs, which those default GC doesn't meet simply. And of course, because we can learn a lot. And not because the current one is bad, because it's awesome, in fact, so it's really, really hard to create something more sophisticated, but still, this is not the reason, but it doesn't mean that we couldn't try to write something better. So, what we have to do to write it? There is a project called local GC on GitHub. I call it custom GC. This project can be tracked on GitHub. It is currently opened. The status during the .NET Moscow, so half a year ago, looks like that. The status now looks like that. And yes, exactly, it is the same status. Because the guy working on it is not longer working in Microsoft, and this project has been a little bit, let's say, delayed. But at least he lived in a state that it is working, so it is good news. There are some things to be improved, obviously, but we can at least use it. And so the usage is very simple. You have to only set one single environment variable to provide the name of the DLL. Since .NET Core 3.0, you will just need to provide the name, and then the library has to be in the same folder when the application, the simplest possible way. And if the runtime starting will see such environment variable, it will try to initialize GC from such file. If you want to be funny, you can set this variable to a random DLL on production and see what will happen. So, implementing. In fact, it's not very hard. It's a regular C++ library. You have to include only 3 files from the core CLR source code. So you have to have core CLR source code on the local machine. And implement, in fact, only 2 simple methods and 3 simple, let's say, simple interfaces. Is it difficult? In general, not very much. I mean, you can start, but in fact, soon you will discover that it requires quite a bit knowledge about the runtime and the GC itself and how they cooperate. So it reminds me this picture. Is it hard to draw all? Obviously, no. You have to only include 3 files and then implement the rest of the GC. And it's exactly like that in this case. talking about those functions, there is one which provides the information which GC API version is being supported by your library. So it just sets two numbers, in fact. And the API is versioned, which is good because they now are able to make some improvements. Currently, it is 2.1, even in the .NET Core 3.0, the version of the GC API. It's easy. And then we have the method which initializes the code. So this method is also required from this DLL that the runtime will be able to initialize GC. And as we see here, the main purpose is to provide two pointers to our custom implementation of interfaces IGC heap and IGC handle manager. This is important because from there, now we are just plugging those custom implementations into the runtime. And on the other hand, we should remember the interface which is provided from the runtime to our code, because now we have the interface which, for example, allows to suspend all threads and restart them or scan the routes, because we need such possibilities from the runtime. So we should remember this interface provided to us. And the king, which is the IGC heap implementation, as we see, as you can see, it contains only 75 methods. So it is easy to implement it, obviously. And we have to implement them somehow. What we have to implement from this, from those 75 methods, if we look about if you look at the comparison between the runtime and the GC, there are so many methods, but a lot of them are in fact used by the current implementation of the GC. If you look at those methods, we will see methods like get GC latency mode, which doesn't make sense in our custom GC because we won't have concept of latency modes, for example, or is promoted. We don't have promotion, so the method is promoted doesn't make sense. And a lot of such methods doesn't make sense in our custom implementation, and we will turn out that we need to implement only a few, in fact. Rest can be somehow implemented in a very, very simple way, as we'll see soon. So, what we have to do to write it? Very, very simple things, yep. We have to implement only those classes, include the few files from the core CLR, and implement a lot of methods, but in fact, most of them will have very dummy implementations, returning true, false, as we see soon. So, how we can writing something which is working, doing something. On our island map, we are starting from the bottom, from the 0 GC island, and the GC which I called calloc-based GC. This is the 0 GC, so it only allocates. Most methods will have very, very simple implementation, like if runtime is asking us, runtime structures are valid? Okay, they are valid, return true. Is being promoted? If object is being promoted, it is not, because we are not promoting anything. And so on and so on. Most methods will be just stopped like that without with one-line implementations. And for my favorite garbage collect, okay, I've just done the garbage collection, no errors, because we don't have garbage collection. The most important for us will be allocations, because those are the most important facility provided by the custom GC. So we have to implement those two important methods, alloc and alloc large, alloc L heap. And this is important because this is the typical path when the GC is being triggered. I mean, in the default GC, there are two steps in those methods. For if there is enough memory, well, whatever it means, it just returns the address of a new object. But if memory is somehow filled, it triggers GC. And this is the approach taken by those methods in the current default implementation of the GC. So we omit the triggering GC because we don't have GC. And the final solution would look like that. For example, I'm here using calloc as a very simple way of implementing. I'm just giving a given amount of memory from the system. So when the runtime wants to allocate X bytes because it needs an object for with the size of x bytes. I'm just calling calloc, which is a system call. The memory is being zeroed by default, and I'm returning the proper address from inside this memory when the method table will be placed. But in general, each allocation just is using calloc. Is it fast? What do you think? It is not very fast because calloc, I mean, we allocate a lot, yep, in our runtime, in our applications, and now every allocation is a system call. So the system call are quite expensive, and the system call is also zeroing this memory, so it is not very optimal solution. But it turns out it works, so it was very, very nice finding. Also, we need to implement handling handles. I mean, handles are a very important part of the runtime. So we need to implement how we handle handles. And we need to implement the method create handle of type, because runtime needs handles, which are just pointers to objects. So I choose the most simplest way that I could imagine, which is just storing them in a fixed size array of handles. Okay, it will just crash when I create more than 65,000 of handles, but it's quite a big number and it was fine for the test. So now I have a very simple implementation where my handles are stored in an array, simply. And I'm storing it also very simple, just operating on pointers. When I want to store an object into a handle, it's just operating on this, that I'm just putting this address into the handle. It's nothing sophisticated. If you are writing something in C++, you are used to operations on pointers like that. They're referencing, putting, referencing, and so on. So in general, this is a very simple implementation of how we can handle handles. And that's mostly all. It turned out that it is working. It is on GitHub. This and all further versions of GC are on GitHub, so you can look at the implementation. It turns out that it was working. How we can run our new shiny .NET custom GC? As we said, we can set this environment variable, so we can just providing the name of it, and the runtime will use it. Or we can use large settings, which is quite a little bit better way of handling it, because we just don't need to care about environment variable. We are just setting it from the launch settings, which will be used by the runtime, by the tooling of the .NET. Mostly because when implementing something like that, we will hit something which is called write barriers, which are trying to be used by JIT and the runtime itself. I'm describing this problem in my talk from Moscow, so I decided to omit here because I want to go a little bit further. But if you are interested, yes, there was one problem, and we should do some magic to fool the runtime that we are not using write barriers, because we don't need them in our custom GC. So there was one single hack, let's say, which allowed to omit it. So what's next? It was working, so I was shocked, because I didn't expect that it will be, but it worked, so it was nice. But the calloc-based allocation is, as I said, slow. We have this single system call per each allocation, and there's memory zeroing. So I decided to implement something which is very similar to how objects are allocated in most managed runtimes all over the world, which is bump pointer allocator. Bump pointer allocator, so it will be the next step in our ultimate journey to the treasure. So we now will be using on the same 0GC island, but we will implement bump pointer allocator, bump pointer 0GC. Bump pointing allocation is simple. It is a concept when we are just moving some allocation pointer. We have these objects, we have allocation pointer, we want to have a space for a new object. So it is there when the allocation pointer points. We are just moving this allocation pointer by few bytes by the size of the object. And now we are just assigned the space for object A, because we just bumped the pointer, the allocation pointer. This is working on something called allocation contexts. So we are pre-zeroing some memory regions to have it that the space is zeroed, so we don't have to care about it. We are just, in fact, really bumping the pointer when we need memory for our object. And this is a simple implementation in pseudocode, something like that, that is just checking whether the current allocation pointer is within the current limit. If it is, just return it as an address of our new object. If it is not, we are going into the slow path, which means we are now have to handle the scenario that the allocation context is full, so we now have to, for example, find new allocation context or even maybe trigger GC. In this implementation, also it is very simple. It's using the concept of allocation context like in this pseudocode, so the fast path is quite fast. It is just checking this allocation pointer within the allocation limit. But on the slow path, the SAT path, let's say, it is just creating a new allocation pointer, which in my case is simple 16 megabyte of data of memory created obtained by virtual alloc call. So I'm just creating these 16 megabytes of pre-zeroed memory regions and operating on them. And this is how this zero GC bump pointer allocator is working. And it was working, suddenly. So I was surprised again, but it was. So in summary, it was quite easy to write an only allocating GC with some very small problems, but they were not very hard to solve. The main caveat here was to discover the problem about those write barriers, which were just being used by the runtime, and it was not obvious that they are. And moreover, this bump pointer allocation is based and is reusing the concept of those allocation concepts, which already are in the runtime, so it was no problem that the runtime was reusing them. It was nice, but it was I was not very satisfied. It was very first step on our journey. So how we can write something at least a little useful, and this is how you please meet the upsilon GC. And yes, it is intended name to be a little bit of pun for the epsilon GC. They JVM have epsilon GC. I'm creating epsilon GC because it's better. And epsilon is further in the Greek alphabet than epsilon, obviously. So now we are discovering in our journey Epsilon Island, which is the island of at least a little bit working GC, which is GC which will reclaim memory, in fact. So it will be a real GC, which could be used somewhere if someone would dare, but we could. So we are starting this quite now complex travel between those two islands to try to implement this real-world GC. But now we are doing a real development. I mean, these allocators that I was showing were working without any debug, in fact. I was just trying to write it. Something crashed, so I improved something, recompiled. Okay, it worked. Now this is more and more complex approach, so I don't imagine that ever I could write something like that without debugging. And moreover, we need debug not only our custom GC, but also the core CLR itself, obviously, because there is no documentation. So unfortunately, the only way is to debug if we want to find something. So we need to compile debug version of the core CLR. Have you ever compiled core CLR, in fact? So it takes a few minutes, let's say that, or half an hour, maybe more realistic. We need to remember that we should, it's better to check the specific tag with the specific version, because then head is not always compiling. So if you ever will be trying to compile core CLR, don't be surprised that the current version, the master, the head is not compiling. It's better to check out the specific version of the runtime. And after some time, you will get the binaries in the debug mode. And remember about skipping tests, by the way, because they took another half an hour. I don't need the tests, so I'm just skipping them. And how you can utilize if you compile the .NET runtime in debug mode? The simplest way would be to use something which is called core run. It is a hosting application, which hosts the, it starts the application using this compiled runtime. It is being compiled with the runtime itself, but it is, yes, it is very easy to run something with it, but it is really hard to run something more than a program that writes console write line hello world. If we have any dependencies, it is really hard to get any dependencies using another assemblies. So I don't like this. I mean, for anything more than one line code, it is really cumbersome to use something like that. So it is much better to take a normal application and somehow use our custom now compiled the version of the runtime. And the most convenient way for me is to use the self-contained application. You can create publish profile, which publishes your application with the runtime itself. So by writing something like that publish profile, which just copies the whole runtime altogether with the application to the specified folder, you have now the folder with the whole application and the whole runtime in the same folder, the default runtime. But we have the binaries of our custom runtime. So without a problem, we can now just copy-paste our custom runtime compiled from one folder to the application folder, and we just overwrite the application, the self-hosted runtime in the application. So in other words, now we have a real application and our custom debug build of the runtime. It is very nice. And in fact, it is suggested way by the Microsoft, because maybe this copy pasting is not very fancy and very advanced way, but it is the simplest way how to use such runtime. And if you would like to test it, we can write such a very simple console application when we can, for example, look at the versions of the compilation of the used libraries, and we will see that in the default example, the build agent was from Microsoft, and our custom runtime should write here that it is built on our local machine. So we will have confirmation that, in fact, yes, we are using our debug build of the runtime. Another approach would be to use custom NuGet source with our debug build of the runtime hosted there and specifying the proper source and configuration of NuGet sources, but it is more complicated for me than just copy-pasting a few files. So I just I'm not liking this. I don't like this approach. So we have now application and we have the custom runtime. I mean debug build of the runtime. And so ADD begins. Do you know ADD? It's a term that I'm coined for this presentation. It is assert-driven development. I mean, you don't have documentation, you don't have anything, you have asserts that will lead you through the development of your custom GC. Because debug runtime in general is much less forgiving. It contains a lot of asserts and trying to, check some important properties of objects and so on and so on. So in fact, it is good because it literally drives us through the development. I don't have any documentation when writing this, so when I hit an assert, I know that something is going on, and I should do something to correct it, and it leads me through the corner to the correct solution. Which reminds me that generally assert strikes us back a lot during such approach, because we will be hitting this many times, and even the first run was obviously hitting an assert. I was not expecting this, but it shows that I hit it. It was a very simple application, and I hit that. I'm doing nothing, but I hit the write barrier violation. Must use set object reference to assign object ref something. I was surprised, so I start to dig in when this assert is being raised, and it is being raised in the code which we are seeing here in the if debug region. So it is the whole test used only in debug, which is using object to object ref as macro, and this macro inside it is only for the checking purposes. That's why it's in debug only in debug region. And this code highlighted here is the source of this assert. If you look into this macro, we will see that it is inside a call that is checking whether the provided address is a heap pointer. So we have this gc heap is heap pointer call. So we are asking the gc whether some object used in our code, no matter where, is on the heap or not. And my dummy implementation was answering if it is not null, yeah, let's assume that it is on heap, which was obviously not very fortunate approach, because not all objects that go through this method are in fact on the heap. So it was not a very good approach, and it pushed me to the very first improvement in my custom GC, that I need to track the segments that I'm creating. Those 16 megabytes of data, and I am tracking, because previously I was just creating them and doesn't care what to happen to it. Now I'm tracking those segments, so I have obviously fixed number of elements, fixed array of segments. And I'm just intelligently answering to this question. Is it a heap pointer or not? Because I know that I have those segments. And if an address is inside this segment, okay, it is on heap in my terms of what heap is. And if it is not on the heap. And this first assert led me to this improvement, assert-driven development. The second run, the first bug. In my application, which was allocating a lot because I wanted to trigger GC, I was using this method GC get allocated bytes for current thread. Do you know what this method returns? Who knows that? This method returns the number of the number of bytes allocated by the current thread so far. It's always growing because it's cumulative number. From the current thread, but it was starting and it was returning negative values, which was quite make no sense that I have allocated negative number of bytes. And if we look again into the runtime implementation of this, we will see that it is using allocation context, but it is using something which is called alloc bytes, which is this number which should be tracked, how many bytes have been allocated so far. Obviously, I was not setting this setting because I was not aware of that. So I started to follow also this path. So now when I'm creating each 16 megabyte segment or any other segment, I'm just increasing the number of bytes that I just allocated those specified number of bytes. And so the story in general continues. Assert-driven development, assert by assert, you can write your custom GC. But in general, Epsilon GC is our real GC, so it should mark and sweep at least. Marking, which is to discover the reachable objects that are currently living. It is no zero GC anymore. So we need this mark and sweep phases. And obviously, let's assume not concurrent approach because it is the simplest one. So we will be marking during the non-concurrent phase. So in general, I plan that epsilon GC 0, which I call that, will be triggering our GC during the allocation. We'll mark all objects in all segments because it is the simplest way I can imagine. And we will sweep unused objects, somehow marking them as a free space. And ultimate goal of this GC would be to reuse this free space by the new allocation context. It will be the simplest thing that I can imagine, but it should at least reclaim some memory. So inside our alloc, now we have a path which should be triggered if we just fill the allocation context. Instead of dummy creating new segment, let's put a place for experiments, which mean now we would trigger GC. It is the place, it is the if marked on the slide. So, non-concurrent mark. For non-concurrent mark, we need to suspend all threads, do marking, and then resume all the threads. we have this luckily we have these two interface methods, suspend EE and restart EE. So I'm calling suspend EE. I'm providing quite decent reason because I want suspend for the GC. I would do something here. Now it's only 3 dots, and I will restart GC. I will restart the threads. And what happens? Who knows what happens? Assert. Obviously, assertion that is hit by the suspend runtime method, and inside it is expecting that the isGC in progress is in progress. I mean, it is true. There is a flag, which is so the suspend runtime method expects that the flag, some flag, GC in progress is true. Okay, so let's create a global flag GC in progress. Let's say by default to false. Before calling suspend is, let's set it to true. Then we are suspending it. We will do something. Then set it to false and call restart EE. And what will happen? Assert. Because now, and it was quite surprising, restart EE in method expects that isGC in progress is true. It was quite, because I'm setting it to the false, yep, and the restart EE expects it to be true. And it turns out that it is because restart EE by itself is setting this flag on its own by the method setGC in progress. So by this assertion, I've learned, because there is no documentation obviously, that I need to implement the very simple method that is just setting this flag, and this flag will be set by the restart EE because I provided the bfinished GC flag to truth, so the threads before the restarting will set this flag to true, to false. So again, assert-driven development, it is always like that. Then we would like to scan the roots. I mean, we have all threads suspended, so we now discover all the roots, so all the objects that are currently living in the threads. And we have now this quite nice GC scan roots method. We are just providing the callback, which will be called for all discovered root. Obviously, other parameters doesn't make sense for us because there are no generations, there are some fine tunings here. For the current GC, for us doesn't matter. We only take care about this mark reachable root callback, which will be called for all discovered roots. And currently it is very easy and simple implementation. It is just printing all those roots that have been discovered. Scan handles will be the second important source of roots, because but here things are a little easier because handles are on our own. I mean, we have this table of handles on our own in our code, so we have full control. We understand how we handle handles, so scanning handles is much simpler in such case. In fact, it doesn't even touch the runtime itself because we have the handle tables on our own, on our side. But handles are very important, because if you look at this poster of the memory management, which I created and you, by the way, can download from the site, we can see that here on the upper right part of the screen there are handles. Those all handles, we have pinned handles, strong handles, weak handles, a lot of type of handles. But those handles are very important from the perspective of memory management because they are used internally by the .NET. So for example, there will be a lot of very important arrays held by these handles. We have thread static handle array, which holds all thread statics, and this array is held by handle. We have statics array, so this is all reference type statics, which are held by this array, which is held by a handle. Then we have all string internet. It is the internet string, which are held by an array, which is held by a handle. So ignoring handles would create a completely disaster in our code. We would not discover all reachable thread statics, string literals, and so on. So we have to start and we have to take care of it. What I'm doing with this different type of handles currently, we have pinned, strong, weak, and other dependent handlers. Obviously, nothing I'm currently doing with this. I'm just ignoring this because it will be the further development to differentiate somehow the different types of handles. So currently, we have this code, which is just scanning roots of the threads and scanning handles and print them to the screen. And what happens? No, it worked. I was surprised, but it worked. I mean, now we are seeing the result of the GC, let's say, I mean the very, very first phase of the GC, discovering roots. We are seeing these roots on the stacks, and there, if you look in details, some addresses are repeating, so some strings are reused, and the method table that we are seeing in the second column, mostly they are strings. This one, which is end, for example, E658. This is a method table of string. As my test application is allocating a lot of strings, so there is a lot of strings references on the stacks. And the scan handle roots also has been discovered. So, yay, it worked. It's very nice. So, being so happy that it worked, I started without any delays, I started to do further development. I have now roots, but the roots are only roots. Now I have to start transitively going into the object pointed by them, and object pointed by them, and by them, and by them. So traversing the whole object graph. So obviously when we have a root, we need to start from it and start through the outgoing references to discover more and more objects that are referenced by them. And beginning was very easy, creating marking, for example, because I want to mark an object. So I just reused the code from the core CLR. Marking is a very simple operation. It's setting a single bit in the method table. So it's like I'm marking objects, which I've discovered. It was easy. But the true story now begins, because now I need to mark objects transitively. I mean, I need to discover outgoing references from an object that I've just discovered. And this is a really sad story, because it was, yes, it is sad simply, because code doing this is completely I can't understand it. It is hidden deep in the runtime itself. We have this path, which will be the most common one, which is if an object contains pointers, we want to discover these pointers and go through them. But the code using it is full of macros in CLR, very cryptic one. I tried to merge them into working code, which compiles, which was a very first step, but at least it compiles. But I mean, it is very hard. It is using the GC info contained before the method table in the metadata, which consists of GC desk series, some mythical way of specifying what pointers an object contains, on which addresses, and so on. And this is completely undocumented. I mean, at least I was not able to find any documentation of that. So I'm just currently at this sad moment of trying to understand this. How does it work? How this method data is and the information about outgoing references is being encoded. It is really, I was not expecting it would be so hard. From my perspective, probably, and maybe it will make sense to try to issue such thing on GitHub, the runtime should provide the API for enumerating our outgoing references, because this code currently, even if it will be working, it will be so highly coupled with the current implementation of the runtime that I don't expect it will be running in a 1, 2, or 3 years. So it would be best that the API of the runtime provides such information. Let enumerate all outgoing references from an object, and it would be very, very nice. But unfortunately, there is no such API currently. So, in summary, writing such custom GC is ADD development, I mean ADD, and get used to that. So, if you even dare to try, which you should, I mean, please help me, in other words. You should be used to ADD. It was quite easy maybe there's 2 or 3 asserts there were, I was hidden by them, but it was quite easy to use this suspend and restart execution engine possibilities. It was very easy to find stack routes. I was very happy that it worked so easy. Even easier was to provide these handle tables, but it is currently very hard to traverse the object references because of this limitation of the API. The rest is complete the say of unknown. I completely don't know currently what problems I will hit in the future. Probably those are small comparing to those which are just waiting behind the corner, but still I don't want to stop. So what's next? In our way how pirates see the world, I am currently trying to reach this Epsilon island, trying to write Epsilon 0, which will be the simplest one, and then this whole journey will continue. So wish me luck at least if you want to contribute to it. Eventually, I am seeing Epsilon GC that it should work like that. It should trigger GC allocation at allocation path. It should mark all objects in all segments. It should track free space in all segments. Let's call it by sweeping, at least to track how many space is free in each segment. If there will be a segment that is free enough, I mean there is a few objects that are living, I would just love to copy them to the another segment, merge all such segments into a new one and reuse the old one. So it will be kind of compacting of the compacting by copying. And I believe if the segments will be quite small, it will be quite interesting to see how such GC behaves in a real world, because it would be kind of experiment nicely to do. So we will see in general how it will work. Wish me luck. I'm going to through this journey, trying to reach this magical land of upsilon. I mean now I'm epsilon. I'm not sure how I will name this ultimate one, GC, but at least I'm trying to find this treasure and make the .NET world better. If you would like to learn more about writing GC, please start from this first book, because it's a completely comprehensive source of any knowledge about GC that has been even invented on the world. It is a big book with a lot of academical stuff. Every possible GC implementation is there, and people are just trying to implement them, in fact. Also, you can try to read mine book, which is about the current one. So what can an author of a book about current implementation of the GC do? You can only write your own. It doesn't make sense probably, because it will invalidate the content of my book. But also, if you don't want to write such huge things, just read these 2 simple blog posts about how I wrote those 0 GCs in a more detailed way, because due to time, obviously, I was doing some simplifications there. The description is more detailed if you would be interested. In general, thank you very much. I'm an author of this book, and I invite you to follow me on Twitter or read my blog, which is all about .NET high memory, high performance, and low-level stuff. So if you like it, please follow me or read it occasionally. That's all. Thank you very much.
Thank you, Konrad. We have some time for questions.
Thank you for the talk. This seems like an absolute hardcore, and does it even worth the ability to build some custom implementations of garbage collector, or the standard one seems okay?
Mm-hmm. I mean, it is working. I was load testing it with a real-world application, for example, ASP.NET application. It was working. Obviously, it was a huge memory leak growing.
No, I mean, does it worth making
it's worth.
it?
I mean, I believe so, because if no one will start it, we will never reach the point when one would be able to create better one than the current one, even if we won't start it even. So, I mean, there is one thing that the current GC is missing. It is concurrent compaction, for example. So maybe this would be the motivation for us.
Was it your motivation, your own motivation, or, for example, some business motivation?
Both, but I mean, after deep thinking, I thought that no one will buy it, so I just open sourced it. But maybe some guy, some woman, someone will just try to reuse it and create its own commercial product. Maybe we will see. It's completely unclear area now. Now I'm just trying to make it working. We will see what the future will bring. Another questions, because I thought, yeah, maybe. I have a question then for a book. I'll let it be simple. What is the name of the zero GC in JVM? Yep. Epsilon or Upsilon? Epsilon, okay. Congratulations. Okay, so if there is no other questions, I believe we're now moving to the
In discussion zone?
Yeah, if you have any more questions, I will be there for a minute.